Welcome to The Explainer. Today, we're diving into a massive biological puzzle, one that affects millions of people. Why is stress the single biggest trigger for drug relapse? We're going to get into the doctrinal research that really cracked this code.
Think about it. Stress is the #1 reason people who are in recovery end up relapsing. But why? What's actually happening inside the brain that makes this connection so incredibly powerful and honestly so dangerous?
To find the answer, we're going straight to the source. We're looking at a PhD dissertation by Dr. Bray that uncovers the exact brain chemistry behind this vicious cycle.
Okay, so here's the core of the problem. When someone is withdrawing from psychostimulants, think amphetamines, their brain goes into this state of, stress hypersensitivity. And what that means is that even a little bit of stress can trigger really intense anxiety and this deep, awful feeling of unease called dysphoria. That feeling, it creates an overwhelming urge to use again.
And here's the part that is just staggering. Despite how serious this problem is, the number of medications that are FDA approved to specifically treat psychostimulant withdrawal is 0. A big fat 0. Not a single one has been proven effective, and that's exactly why understanding the biology here is so critical.
So to really get why current treatments just aren't cutting it, we need to zoom way in and meet the key players inside the brain.
This whole story basically plays out across two really critical parts of the brain. First, you've got the ventral hippocampus. You can kind of think of it as your brain's emotional mission control. It helps manage feelings and stress. And second, there's the famous nucleus accumbens. That's the reward center, and it's all about motivation and making you want to go after things.
Now for the chemicals. Our first character on the scene is corticosterone. In humans, we call this cortisol. It's the main stress hormone that just floods your system when that internal emergency alarm goes off.
And our second character, of course, is dopamine, the famous motivation molecule. It's the chemical that makes you feel good, makes you feel rewarded, and drives you to pursue a goal. Now, the way these two chemicals interact, that's where our story takes a really interesting turn.
So, to figure all this out, the researchers set up this fantastic core experiment. They had to see exactly how these brain chemicals were behaving during withdrawal. The experiment itself was pretty elegant. The scientists took two groups of rats, a control group and a group that was going through amphetamine withdrawal. Then they exposed both groups to a stressful situation and measured the corticosterone levels right there in the hippocampus.
And boom, the results gave them their first major clue. That first bar shows the stress hormone response in the normal rats. But look at the second bar, the one for the rats in withdrawal. It's a massive spike. Their brains were just flooding with way more stress hormone, even though they were reacting to the exact same event.
And the dissertation says it pretty bluntly. The state of withdrawal actually supercharged the brain's stress response. This wasn't just some tiny change. It was a fundamental rewiring. And it set the stage for something dramatic and completely unexpected.
Because this massive overreaction to stress, it leads to the single biggest and most surprising twist in this entire story.
So this led to the million-dollar question. What does all of that extra stress hormone actually do to the dopamine system? How does this huge corticosterone spike in a withdrawn brain affect feelings of motivation and reward? And the answer was a complete, shocking reversal. In a healthy brain, a little spike of stress actually gives you a boost in dopamine. But in the withdrawn brain, that very same stress signal caused dopamine levels to absolutely plummet. It just crashed. The chemical that drives motivation was suddenly gone, creating that awful feeling of dysphoria.
So how is that even possible, right? How can the same signal produce the complete opposite effect? Well, the answer is found when we look even closer, at the tiny little receptors sitting on our brain cells.
It all comes down to a two-receptor system that controls how our cells listen to stress hormones. Think of it like this. You've got one type of receptor, the MRs, that act like a gas pedal for dopamine. Then you have another type, the GRs, that are the brake. Now, in a healthy brain, they work together in balance. But what this research shows is that amphetamine withdrawal rewires the whole circuit, making that brake signal way more powerful.
So let's put it all together. Here's the key. When stress hits a withdrawn brain, that huge flood of hormones hits this now unbalanced system. The superactive brake signal completely overwhelms the gas, and the result is a net crash in dopamine. And that, right there, finally gives us a clear biological reason for that terrible feeling that fuels relapse.
And this isn't just a fascinating piece of neuroscience, you know? It has profound, real-world implications for how we understand and, maybe more importantly, how we can start to treat addiction.
So let's recap the chain of events. 1. Withdrawal makes the brain's stress alarm go haywire. 2. That alarm then flips a switch, making dopamine crash instead of rise. 3. This explains the awful feeling that drives relapse. And 4, and this is the most important part, it points to a brand new target for therapies.
And all of this leaves us with one final, and I think really hopeful question. What if we could develop a medication that doesn't just paper over the symptoms, but one that actually targets and rebalances this specific stress receptor system in the brain? Could that, finally, be the key to breaking the cycle of stress and relapse for good?